So welcome to the stage, Joe. So
It's my pleasure.
Yeah. So I've been a huge fan since the TEDx talk and about WIKISPEED. And then there was another TEDx talk recently, and you know, looking at the resume is super long. Many of you got it from the email, and I tried to print it. You know, some of the things here. And so, what are accomplishments during your career you are most proud of?
WIKISPEED changed my life. Getting to build hardware in short cycles ended up making a business. But what was so important to me is finding that you could just post on social media what you were most passionate about, and other people who were passionate about it would find you, and it would create an organization organically. Now, from there, I got to work with companies that were my heroes, and that's where the resume builds. In consulting, sometimes it's just 2 days. Sometimes it's a year in a company, but still you get to go to dozens and dozens of companies, and that's where the resume builds. Working at the Bill and Melinda Gates Foundation also changed my life. Getting to collaborate with Google changed my life. And then most recently, operating Agile at Tesla from Tesla's global headquarters in Fremont, California. During their huge stock price rise, I learned a lot. And that's a highlight for me, for what I'm proud of. Thank you for asking, Hika.
Yeah. So today you are going to talk about Agile hardware. So Lean has been really established in the production industry for decades already. And I haven't been hearing that much about talk about Agile hardware in Finland. So how common do you think it is in globally or in States?
Hardware, it looks like Agile is where software was, maybe right after the Agile Manifesto was written, maybe 2004, 2005 times is how hardware feels. You have your early adopters that are doing it at scale and methodically. You have your companies that are on the avant-garde, like Tesla, with very short hardware cycles. And most companies worldwide are now curious about it, which is, but not doing it yet. So you have John Deere doing it, you have part of Toyota doing it, you have part of Bosch doing it, you have Daimler wanting to do it, you have BMW wanting to do it. But most companies in manufacturing are only asking about it, or they have a pilot project. Only a few top to bottom, and those are mostly new companies like Tesla.
So Agile makes quick learning cycles possible. And what happens when you apply this in hardware?
So I think this is frequently misunderstood, and Marit Lantil is trying to connect me back to most of the world. So I'm companies that are doing hardware cycles in less than a day, and they're doing design, analyze, build, test, deploy in less than a day, continuous release. And most companies are saying, no, we still want 1 year, 3 year, 4 year hardware cycles. We can't yet imagine shorter than a year. We just want to learn how to Jira. And so they call me and or whatever they think Agile means. They want to be compatible with their happy Agile software companies, software groups. They call me and I say, great, hardware every day. And they don't know what to do with the information. So a piece I'd like to share from Finland is Marit Lentil has created a Agile hardware class in Finland that she's now doing online globally. And I've had a chance to go through all the course materials. And I think that is what most companies need to increase their agility. It meets them where they are now, which is 3, 4, 5, 6, 7, 8 year long hardware cycles, and allows them to establish the groundwork so they can start having Agile teams to move towards these short cycles you just talked about.
Okay. So, Joe, floor is yours.
You're so kind.
Yeah, please, I will drop off. And your slides are showing, so I will just drop off and you can continue.
Don't leave me alone, Hika. You're going to drop off. Everyone, thank you very much. It's been a dream of mine to be part of ScanAgile for a long time. And this speaking engagement has been more than 6 months in the making. And I would like to apologize to all the people working in or working with the beautiful major hotel, the Clarion Hotel in Helsinki, when the original physical ScanAgile 2019 had to be delayed and deferred and moved online because of the COVID crisis. That's got to be a huge financial stressor for that entire industry. And I hope to stay at the Clarion Hotel as soon as possible to give them service, but more importantly, to meet with all of the business connections that I'd been so excited to meet with as part of ScanAgile in person. Now, the Remo software ScanAgile is using is really good, and I can't wait for after this presentation to sit at different virtual tables and video chat with folks from all over Scandinavia and the world with a particular interest in learning more about the Scandinavian companies, the Finnish companies, the Helsinki companies that I was hoping to meet in person. And as soon as ScanAgile can be physical again responsibly for everyone, I can't wait to come. So thank you. I'm glad this is happening. It's been a long road. Thank you, everyone. I'm JOEJUSTICE. I am chair of the Agile Business Institute. We help conduct executive-led Agile, and I want to share about Agile Hardware. May I have the next slide, please? Here's a ratio of how fast new products are deployed, and then the perceived value of the company by total market capitalization, total stock value. You see a clear correlation. The faster companies complete products to market, this in hardware, we don't call it cycle time or release time as often. For the entire product, it's typically called NPI, new product, and that happens after NPD, new product shipment. I'll use those terms as that's the majority term in the hardware industry. You can see the faster the NPI or NPD, the more the company is worth. In hardware, 2.5 year hardware cycles from idea to in production is pretty fast for most companies. Tesla's at 20. Next slide, please. I'm lucky enough to work at the executive level with major hardware companies all around the world, and here are quotations from them. I'll read it for us. The first in Germany, but a global company with more than 300,000 employees, Volkmar Denner, the chair and CEO of Robert Bosch GmbH. He is a direct client of mine. Thank you so much, Volkmar. He says, for Bosch, agility is crucial. It allows us to adjust to the increasing speed of change around us. It allows us to remain in position as an innovation leader. Then Toyota, the CEO of Toyota, his son, Daisuke Toyota, is the direct client of mine. I was brought in to train everyone in Toyota's advanced research and development, where they work on their autonomous driving, and where Daisuke Toyota, the next CEO of Toyota, is. And I trained him in Agile Hardware. And the current CEO says, when you look at a product going to the actual sites, going to the gemba, which is Japanese for the place the work is actually done, not where it's planned, but where it's physically done. What is important is to fuel the change point. Herbert Diess, CEO of Volkswagen Group, who my partner works with directly. The big question is, are we fast enough? If we continue at our current speed, it is going to be very tough. And then Elon Musk, who was my CEO directly, says pace of innovation is all that matters in the long run. The common thread of all these executives is they're all talking about speed. They're talking about Agile for speed. What I love about agility is how your feelings are so important, the connection as a team, so that we can mob, we can make cross-functional work, we can pair, we can swarm. The team love is so important, and we have higher morale. From the executive perspective, it's speed of new product introduction. It's speed of new product development and speed period. So I'll focus the rest of this talk on the speed implications of Agile and hardware from the business lens. May I have the next slide, please? Yes. Agile is being used in public-private companies globally, the US Department of Defense, the Australian Department of Defense, Lockheed Martin, Raytheon, Google, Amazon, Microsoft, Boeing, Airbus, Hewlett-Packard, Tesla, Toyota is trying, MIT, MIT Sloan Business School, Siemens, and more than 100 others. These are all companies I've either been brought in to teach classes or consult to the executive group. They are all working public-private. May I have the next slide, please? And now, depending how the majority of the world's finances are managed by Agile companies. These are all clients that are my clients or my partner's clients. Royal Bank of Canada has 7,800 employees, and the assets under management are more than 9 billion Canadian. ING Bank in the 54,000 employees as of last report. Their assets under management is, sorry, the slide's a little small for me to read, but hopefully you can. 887 billion euro. Pictet Bank in Switzerland, 554 billion Swiss francs assets under management. Capital One in the US, 372.5 billion US dollars assets under management. These are all companies with public Agile transformations. You can go to their hiring pages and see they're hiring Agile coaches, Scrum Masters. What's actually happening in these companies is really similar to the Spotify model, which Henrik Nieberg says, don't call it a model. It's simply a snapshot in time of what Spotify was doing at the time. And in fact, they're even doing different stuff now. And then it's very similar to what Paul Tacken rolled out across ING Bank. He's my best friend, Paul Tacken. I have tremendous respect for the work he does. And it's a lot like how WIKISPEED works. Many of you have seen the TEDx talk I was lucky enough to give on WIKISPEED. And we divided the car into modules. Each module has a team. That means we have test capability in every team, design capability in every team, build. And build for us isn't, there's some programming, there is, but it's also physical skill, like machining aluminum or laying up carbon fiber. So we have those skills across teams. We then do have communities of practice or even quality circles. I didn't evolve to the point where I had for tribes or guilds at that time, but the idea of the modules creating the company structure, it ends up looking a lot like what Spotify was doing at the time when Henrik famously reported it. I've been trying to find a word that's not copyrighted to describe how these teams work together. So I just call it group scrum. That's it. I'm just saying there's a lot of teams working together. May I have the next slide, please? Regulations are embracing this stuff all around the world. The Food and Drug Administration in the United States determines when medicines get to be released, or implanted medical devices, or robotic surgeries, or surgery tables. And they publish a waterfall diagram of the approval process. However, the current FDA law says waterfall is only appropriate for the most simple and trivial products. They say for more complicated products, they actually need concurrent design, engineering, and test. Starts to sound pretty agile, right? Then they say they need fast feedback loops, and they say the device compliance file, the file that says what method was followed, what phase gate reviews, they say that's for the person making the device anyway. It's not for the FDA. So the FDA is now pushing agility, and we're seeing that in regulation bodies all around the world. We're seeing implanted medical devices, medicines, hardware, and often with embedded software and apps to manage cycles by the governing bodies. Next slide, please. I'd like to show an example. Here's Volkmar Denner, Chair and CEO of Bosch. Next slide, please. The step one for Bosch, my perspective, is first, Volkmar called my mobile phone directly. I was starstruck. I'm so grateful for that direct client introduction. I worked with Volkmar one-on-one in an executive session. Then I was brought in to give a keynote to introduce the concept to all the top management at Bosch. It's a 300,000 person company, so the top management team is 500 people. That was a 500 guests, very elegant, nicely dressed keynote. And then leadership workshops with all of the executives to explain what this Agile and hardware is. And then I went directly to work with the product teams. What you see on the left is part of the sprint review of sprint 1 from a hardware team. The point I'd like to make is Agile hardware releases hardware every sprint. There's a lot of companies that aren't ready for that. They want to move towards Agile hardware, but it's fully possible if the company's excited enough for automated test, robotics in manufacture, the same stuff that works in Agile software, automation, scripting, it's the same, just you have physical robots instead of only scripts. You can deploy hardware every week. So on the left is a 1-week sprint, and that's how much hardware was actually completed with embedded software. Next slide, please. Here are the next 4 sprints for 5 sprints total. You can see every sprint, there's a new enclosure, there are new circuits inside, there's a new sensor suite, and there's new software triangulating and interpolating the sensors. This is an anti-collision sensor for freight locomotives, for freight trains. And in sprint 1 and 2, they needed a wiper to have a clear enough viewpoint for the sensors to behave properly. By the end of sprint 5, which was week 5, the software had evolved to the point, and the electronics and the sensor plate, they could see through the enclosure well enough, and they went to sale. So they went on sale in 5 weeks, with each week ending with the customer tested on freight locomotives. In fact, they tested almost every day on actual freight locomotives. And every sprint ended with giving the customer hardware and software. Here's what it looks like in production. This is a picture from inside Tesla, and here's a picture of me at Tesla. I don't get to share pictures from inside Tesla. So I found one that Elon Musk shared because he's allowed to. And if Elon has shared it, I can then share it and talk about it. So I'll show what's going on here. You can see it. This is the assembly of a Model X. And in fact, it's, well, I don't get to talk about that. But what you can see is the robots have flexible hands because 7 changes in hardware a week. So you have teams of humans, agile teams of humans, designing in real time, offsite and on-site, all around the world and physically in the plant. And they're deploying in real time new hardware to the robots to assembly. So this is what a build server looks like in hardware. In hardware, a build server looks like a team of robots, but they're not making the same build every time like traditional mass production. Instead, it's a true compile. They're taking new components and integrating them. That's why they have flexible hands. The next step is these build components have an API. They have an interface. You can see these flat mating sections. They're not always flat, but they're mostly flat to simplify the engineering and the mating. That means any other part of that module can change, but the modules will still physically connect. Now, those interfaces, I didn't realize this at first, it's perfectly fine for them to change at any time, as long as the design teams, the development teams, the manufacturing teams of both modules that share an interface agree during the same cycle, the same sprint. And there's a quotation from me below that really is the whole point here. Automation in software and hardware and management with test in the loop is, in fact, the answer. Humans are for creative problem solving. Automation is for everything else. This is what actually gives us the speed. And when I'm working with executive groups to establish agility, it's all about increasing the level of automation and increasing of the human. More people, and we end up having a lot more robots. Lean, the Toyota production system, is famous for what's called one-piece flow, where trucks unload stuff to build, and the parts flow through lean cells, and we iteratively manufacture the thing. Then it's sent to test in an adjacent facility, put back into stock, and the final good is shipped. This is great for making the same thing again. Problem is, if we want agility, if we want to reduce the cost to make change, single one piece continuous flow is actually really expensive to change. It's not agile. So what does agile manufacturing look like? This is a view looking down at a factory. Next slide, please. Here is agile manufacturing. This is what it really looks like. You have a huge stock backplane. By that, I mean a massive wide warehouse. And you have continuous funnels of either carts or automated carts or conveyors. And they're dynamic. The stock is dynamic. And it flows to these agile manufacturing teams. And it's not linear. It's not single one-piece continuous flow. The flow is on demand because it changes all the time. What the teams are building changes all the time, more than 27 times a day. And then that flows to the stock front plane where we have continuous integration. Now, continuous integration is test, and we go through all automated test at continuous integration time. And because we don't want to ship low quality, the products have to test themselves. In Tesla, that's where autopilot came from. Publicly, you can see it. You can see videos on YouTube released by Tesla showing inside Tesla, the cars have on the screen what's called factory mode. That's the original autopilot. That's the cars putting themselves through all required test. So you have self-testing product, because if every car is a potential enhancement from the car before, every car must test itself. So instead of trying to constrain change so you don't have to retest, you must embed the ability for the product to test itself. Now that has side benefits. You now have the bones to build what is now autopilot or some level of self-driving. If you want to know more about what makes this work, I highly recommend Kelly's book, Scrum for Hardware. The second half of the book explains all of the technical practices of extreme manufacturing as I learned it and then have been doing it in these companies. Next slide, please. This is working in construction now too. In COVID times, in the US, it typically takes many years to build a hospital. In COVID times, some hospitals were built in as short as 3 weeks. And what happens when you construct a building in as short as 3 weeks is the buildings are made module at a time, and each module is a complete mini hospital. Each module has heating, ventilation, air conditioning, sound deadening, insulation, life support systems, operating hospital beds, and operating equipment to give care to the people in the hospital beds. So any one of these modules is functioning standalone. Well, then they're connected side by side and on top of each other at the rate they're completed, because they have a stable interface on the sides, and you have stable hallway portions and hallway modules to connect them, your architecture, your infrastructure architecture, and you can grow organically. And that allows construction in 3 weeks. Next slide, please. This is exactly what Tesla does. Here is the Tesla Gigafactory in Sparks, Nevada. What I'd like you to notice is it's built in modules. And from the moment the first module is built, manufacturing inside is happening, design inside is happening, employees inside are working. And as new rectangles or squares of the factory are built, cubes of the factory are built, people immediately start working as they're built. And what you don't see in this picture is each module that's not yet deployed, there's tents there. And you can see this on YouTube, so I'm not releasing confidential information. There are tents outside wherever the factory is not yet built, and there's already manufacturing happening. So from the first day Tesla announces they're in a site, there's already production operations there. And they don't wait till the facility is completed to begin work, obviously. So they complete the facility in modules, and people move out of tents and into the facilities as it's done. Now, in their partner companies, in the inset picture, sorry, previous slide, please. In the inset picture, you see they're using what's called modular Z-axis manufacturing. It's where they build modules up on top of existing structures. That factory in the inset is in Fremont, California, where I was working, the global headquarters. And that's an active building. People are in this building, and there's an active construction site on the roof of the same building and people are already working in that building on the top as it's being built. And there's tents all around it where people are working, anticipating the new building to go up. So we have modular XY construction, which is easier to see in the Gigafactory, and modular Z construction, which you can see in the inlet. I had a wonderful Twitter conversation with Peter Stevens from Zurich, Switzerland, and we were talking about how flexibility and predictability, you can have both when you have modularity. And as a result, we're teaching on Zurich time a executive course on how to run an agile transformation for product companies. Next slide, please. This works in jets. Famously, the Saab Gripen in Linköping, Sweden, has 3-week sprints for their jets. Also, the F-35 stealth fighter and the F-22 stealth fighter also have agile components, and I've gotten to consult directly with the leadership teams and the manufacturing teams and the design groups and the procurement groups, which Mirko Kleiner has brought to a refined discipline with agile procurement. That's exactly what's happening in these jet fighters. Next slide, please. Here is Jürgen Sobatoft. He's the head of software for the Saab Gripen, and he says something amazing about hardware. This is a video on Saab's so I can talk about it. He says, reconfigurable means we can add applications without having to requalify the platform. This is key for my clients who are doing Agile and hardware. They need to get permission that their own tests are the gated tests and they can use the product in production. This is how they get down to 3-week releases like Saab Aeronautics, Saab Defense does with the Gripen. Jürgen Sobatoft then says, we can even swap the hardware to revalidate. And it's funny, he says it from a software perspective. He's like, software can change anytime and we don't have to retest the plane outside. Our own testing is valid. He says, then we can even swap the hardware. He says it casually because that's not his domain. He's a hilarious guy. I really enjoy Jürgen. But they can switch hardware modules in and out of the plane. That's been negotiated with the governing flight certification body. To do that, this plane has to be fully tested every 3 weeks. So all that testing that was previously external vendors had to be brought in-house. And in exchange, they have 3-week releases of the jet. Next slide, please. That enables frequent releases in hardware. And so you see frequent releases, iterations of the jet. Next slide, please. Now it makes sense, if you're releasing as often as 3 weeks, it makes sense to have customer on these to make sense when the feedback cycles are so fast. So they have 8 pilots on site. Next slide, please. And it's happening in commercial aviation. I've had a chance to work with Mitsubishi Aviation and with Boeing on their next aircrafts as well for Agile hardware. Next slide, please. The way this works is I will first request a survey of all employees to say, how are you actually working in your own words? So I have their understanding of how they actually work. Is it in phases? How fast is it? How flexible is it to change what's being worked on? What level of automation exists? So I start with a retrospective run by the people doing the work. Next slide, please. And then everyone goes through a certified Scrum Master class. Now, the way I teach a certified Scrum Master class, I think is different than anyone in the world. I cover the same learning objectives that the Scrum Alliance requires. They're still useful to me, but it's presented in a hardware forward context that assumes you also have application development and embedded software to make the entire product. And it assumes the management is also on these same Agile teams, including the board of advisors and the investors, so they can fund projects within 1-week sprints or 1-day sprints. So the whole organization is on the cycle. So everyone in the company goes through the certified Scrum Master class the way I teach it. Next slide, please. And I know it's working when every team has a visible Scrum board. So management and all teams can see what's in doing across the whole company, what's in done, what's coming next, who's currently playing the product owner role, because I enforce that role rotates to avoid hierarchy, and who's currently playing the Scrum Master role, which I also enforce rotates to have a wide view of how to remove impediments. And we have team names that people can rally around. Next slide, please. And this creates a group Scrum board where every team has a row, and each team reports how much money they spent the last sprint, their burn rate, because they're building hardware, right? And if the company is already releasing in less than a sprint, like Tesla does, they report how much money they made. So you have money in and money out per team, per module, and teams own modules. You also have a quality metric and a speed metric, and the x-axis is sprints, and it flows infinitely in a digital board. Next slide, please. In Group Scrum, we run 3 daily scrums. One is about, are we building the right product? It's very similar to what Jim Copleen writes of what the meta scrum is. The development team talks about quality and engineering practices, which is a little different than the way daily scrum is typically run, but that's what I need to keep quality high. And the Scrum Masters talk about continuous improvement for speed reasons. And it's not speed of manufacturing the same thing nearly as much as it's how quickly can we change? How quickly can we reprogram the manufacturing robots? How quickly can we change what product is input into each lean manufacturing cell? And how quickly can we pick up different product from each lean manufacturing cell? So they Kaizen change speed. And these 3 meetings happen and in about 3 minutes if they're run every shift. Next frame, please. In some companies, these meetings are once an hour because they're fast enough. And it looks a lot like the Spotify model. Each team has a module. Each team has a product owner and a Scrum Master. And the company operates as company as a service teams, where you have a facilities team, you have a funding team or teams, you have a coffee team. Truly, like this is all over Silicon Valley. All of these mega companies in Silicon Valley, for example, have a coffee team and a gourmet team. And they all insist that world-class cuisine, if they can do it, is available hot every 3 to 4 hours around the clock, 24 hours a day. And that handmade, barista or barista-made custom coffee is available 24 hours a day by real humans. That's required for people to work at this pace and have fun. This is what I do now call the WIKISPEED model. And I just mean you split the product into modules and teams own the modules. And then you have company as a service, agile teams with backlogs and product owners and Scrum Masters to provide the infrastructure the company needs. And that's it. It's totally flat. Next slide, please. I finally named something after me. If you like it, please use the term. I'd feel great. It's a variation of Conway's law from the 1960s. Justice's law. It's the modules of the system define the structure of the organization, or the modules of the product define the structure of the company. This is how I restructure companies. I've had an opportunity to do that a lot since WIKISPEED, since what I learned with WIKISPEED. And it really is that simple. It's what are we actually making? What's the hardware? What modules compose the hardware? Well, there's your teams. And we don't have separate mechanical engineering or software engineering or procurement. It's too slow. If you want 27 releases a day, like Tesla, it's cross-functional teams per module and it's flat. It's a totally flat company. And there's no such thing as a chief product owner or product owner team. It can't keep up with that pace of change. It's too slow. That's a maybe necessary incremental step to get toward this for many existing companies. But you can't do multiple releases a day with something that top heavy or vertical. Vertical integration does not mean vertical stacking of headcount. Next slide, please. The way this is done is the big projects are split into small and extra small projects. So the architecture of the system determines its release speed. Next slide, please. And this is exactly how real companies do it. Here's me at SpaceX headquarters in Hawthorne, California, and you see the Falcon Heavy rocket, an extra large project, is composed of three large projects, 3 Falcon 9 rockets, and those are each composed of 9 Merlin engines, which for SpaceX is a small project. They make new Merlin engines every week, and Elon Musk has famously said no 2 Merlin engines are ever the same, because they're continuously improved. It's agile, right? It's continuous release. So you have 27 small projects and they compose the large project. Next slide, please. The Standish Group has been saying this since 1985. The Standish Group tracks hardware projects and software and furniture and finance all around the world. And what they've found since 1985 to present is large waterfall projects have the highest failure rate, the highest rate of all money spent and nothing ever delivered. And small agile projects have the highest success rate, the highest rate of on time, on budget. So by splitting these large projects and extra large projects into many small and extra small projects, we get a faster release speed, a faster new product introduction and new product development speed. And the risk of the project goes down by more than half. So that's what's working. It's splitting these big projects into small stuff. The modularity is really that important. Next slide, please. And then we track it on burn down charts, just like many software teams do, or burn up charts. They both work fine. So each team tracks their own module by versions of their own module improving. And then the group Scrum board aggregates all the modules of the product and gives real-time projections of when all the modules of a system will have a complete turnover, which means a complete refresh of the product. So it's all measured with burn up and burn down charts. And if you have multiple releases a day, like Tesla does, these burn up charts are updated every few minutes. If you have a release once a month, well, then these charts are updated at least once a month. So it all depends on how fast the company is now. And that's governed how small the projects are and their level of automation, their level of automated test, and are the humans truly doing the design work and the robots are doing the heavy lifting, right? That's actually what governs the speed, is the level of automation. Like just like DevOps, just like automated test and deploy accelerates app development and software release, it's the same in hardware, except you have actual physical robots and lots of them. But now the speed to reprogram the robots, that's your speed to change. Next slide, please. Monotasking. For 6 years, I tracked how fast monotasking of one project at a time was versus 3 projects. I did that in more than 20 countries with more than 3,500 Agile hardware professionals. And I found working on one project over 3 was 500% faster. So that's the same you've been doing. May I have the next slide very fast, Hika?
Yeah, one more slide, so we have some time for the questions then.
Next slide. I'd very much want to show the closing. So I wish I could just click. Here, there's Agile hardware training in Finland now. I've seen these materials from Marit Lantel. They're excellent. I'm not part of this training. I don't make any money when it runs. Maybe I'll co-teach or get some partner thing going on at some point if that really helps people. But the materials are excellent. And I do think this is what will bring Agile hardware companies towards hardware. I highly recommend investing in these courses. And I think there's a closing slide. It's a free link to download Paolo Samichelli's Scrum for Hardware book. Yeah, there's me. You know all about me. Please connect with me on LinkedIn, Zing, Twitter, Facebook. And I thought I had a promotion for Paolo Samichelli's book. Please do download the free preview of Paolo Samichelli's book from LeanPub. It's an Agile published book. The first half of the book, embarrassingly, is a history of how Paolo and I know each other, which for me is just, I mean, we do cool things, but reading about yourself that way is very embarrassing to me. The second half of the book is extreme manufacturing. I highly recommend it. And there's a free preview. I'd recommend reading page 13 and 14 of the free preview and deciding if you want more of the book. And then please do buy it. It helps Paolo. And he's a genius coach. Yeah. And Maria Mattarelli's Personal Agility. will
the
put your
slide on
goals
the
in the
text
backlog.
of this, that was in the chat. Yeah, Joe. So we have so many questions. So, we already went nicely over, but I'd like to, I would really like to ask some questions for the participants. So what are the biggest challenges you have faced with Agile hardware?
If the company's Agile native, like Tesla, or like some of the rocket companies now, like Relativity Space, like SpaceX, the challenges are more about finding investors that understand that you're going to be reinvesting in product mix daily, right? That the actual financial management is daily. And that's where Agile procurement, like Mirko Kleiner teaches, is so important for these Agile native companies. For existing companies, their current written processes are the primary bottleneck. And they'll have a 3-month planning phase. And then they'll have phase gate reviews, and that will potentially repeat, right? Well, they're not funded to build more than one test part during that planning phase, sometimes none. And so they build in the waterfall. They build in big planning up front, and they make NPI and NPD slow. New product introduction and new product development slow. So the process needs to be republished first. So I think it starts with the project management organization for existing companies. I think that's the biggest hurdle.
Okay. And the next question here is, does sustainable pace still play a role in this, or is fun compensating for the length of day? Yeah.
So fun solves a lot of problems. Morale as a multiplier for velocity solves a lot of things, and it can solve it for you. If it's truly engaging, if it's in line with your life mission, you can do a lot for a long time, maybe even forever. But there's still a limit. It looks like speed is still higher if you have a 24-hour work cycle. So when I was at Tesla, I would do 12-hour shifts. And when I would leave the next person, we would have an overlap, and then again the next morning in 12-hour shifts. And I think that is sustainable forever, especially if you're really excited about it. It's got to be really fun, really, 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 really fun. But to go this fast, nutrition becomes more important than it ever had. Quality of sleep becomes more important than it ever had been. So there's it's like a professional sport. So you take your rest and your training and your nutrition more seriously than I ever had before. But then, yes, I think it's sustainable then.
And then there's the next question. So there's so many questions now. What goes into the initial planning of a new Agile hardware project?
Well, when these projects are really fast, I mean, these are huge projects, like changing massive systems. But the designs happen in modules, and they have in-house tools. So they drag and drop huge components, and they stretch and change in 3D CAD, and you have real-time stress testing. Like, it's a lot about the speed of the feedback loop at design time, and then the flexibility of the manufacturing system. When these projects are 1 day or less, planning is a whiteboard session for maybe a few minutes, a virtual whiteboard session or in-person whiteboard session, because you don't need to plan that long, even for major changes, if it's really fast to deploy them and if it's really fast to roll back. Something I don't think a lot of companies have realized is speed of delivery is dictated by how fast can you roll back to the last known working version. You can deploy a model to manufacture a car. If it's in 5 seconds, you can roll back the robots to now resume manufacturing the previous design. So you test and compile, and maybe you have to scrap one car. It's so much cheaper than a lengthy design cycle holding that innovation back for weeks. So the planning cycle is really short and almost trivial when the changes are that fast.
And then there's the next question from Sami. How do you avoid the semi-cobalt problem? I don't know this problem, but
One more time.
no one knew how the car worked, and that led to accidents. Sami, do you want to ask this on stage? Sami, do we pull you on the stage? He's brave enough. Mika, can you pick up Sami to the stage and he gets to ask this himself?
I'd like to learn.
Yeah.
While that's happening, I really am thrilled to be part of ScanAgile.
Okay,
I can't wait to do this in person when we can.
Yeah. So
can you hear
Sami,
me?
please. Yeah, thank you, Sami. And if you
Okay,
can
so,
turn on your video, please
yes.
do.
Yeah, I cannot because well,
Okay.
no webcam right now.
Yeah.
And
Okay.
yeah, I wanted to ask
I
about.
respect.
I'm pretty sure you're familiar with the problem with Chevrolet Cobalt, where they had ignition issues, and basically, as at the Congress investigation to the accidents, they figured out that no one at Chevrolet knew how the car worked, because all the teams were part of specific parts of the whole. So since you are advocating a modular approach to hardware, I wanted to ask, like, how do you avoid that particular issue? So what happens when you have a problem, and so how do you pinpoint and figure out how the whole system works and not just the individual modules?
Sami, I love it. What seems to be working is at Chevrolet at the time, the division looks like you had a procurement group, you had several electrical engineering groups, you had several software groups, you had several mechanical engineering groups. So their skills split. When we have module split with cross-functional teams, the level of understanding of the module becomes very high. Then the modular architecture, there are sub-modules, and yeah, there ends up being a lot of modules, but it's never more than 3 layers deep. Here's what I mean. You have an engine module, and yeah, the engine has a stator, and there's winding and sub-modules and subsystems to help make the motor part of the motor module work. But there's only one module above that, which is the whole car. So you have entire product modules, 8 or less, and then you might have sub-modules. But because there's never more than 2 levels above wherever you are ever, the people understand how their module fits in the whole system, and this avoids the problem. That seems to be also related because the product isn't split by skill, it's split by entire module, which includes software, which includes hardware, which includes electrical engineering, which includes procurement. Every module does.
Okay, I think we can continue with the questions forever. So, you know, I think we need to wrap up, but Joe will be on the table, speaker table on the first floor. So please go to Joe and still ask questions. So we have after work after this. And then thank you, Joe.